Hi everyone! In this video, we are going to expand the dataset by adding more domains and languages. You will learn how to find multilingual embedding models on Hugging Face. We will also run different benchmarks to see if the performance stays consistent when we change the language of the questions or the text chunks. In this step, we are going to expand the dataset. We are going to add more domains and languages to see if the models can generalize. The goal is simple. We want to test if these models actually understand meaning across languages, or if they just got lucky on the small English test that we used in the previous video. This is the table that I showed you in the previous step. We saw that the Qwen 3 embedding 4 billion model performed better than the other models, and in this video we want to see if this model can keep its top spot when we scale up the data. Here is how we are going to do this. First, I added new PDF documents to the documents folder. Then I ran the notebooks again to generate questions and text chunks from these documents. Finally, I generated the embeddings and saved them as JSON files. For the multilingual part, if you don't need other languages, you can skip this. But if you do, you can translate the text manually or use an LLM to get a good result. I have created 3 notebooks for that. The first one uses Gemini, the second one uses OpenAI, and the last one will use a new open source model that is called AIO. This one was trained on a lot of languages, that's why I included it here. Once the text is translated, you generate the embeddings for the new language and save the JSON files, like I'm showing you here. And these files are available on Hugging Face. You will find the link in the video description, or if you check the GitHub repository, you'll find a link that will take you to the Hugging Face repository where you can download these datasets. When selecting an embedding model, make sure that it was trained on the language you are targeting. If you pick a model randomly, you might download a model that doesn't support your target language. The results will be very, very bad. Here, for example, I am showing you the all-mini LM model. And as you can see, the scores are almost 0. So here we have MRR is 0.07. And if I average all these scores, I get 0.06. And the all-mini LM was not trained on the Arabic language. And here I have benchmarked it on that language, and it performed poorly. That's because this model was not trained on that language. So this is why I'm saying that it is very important to read or to find if the model that you are looking at is able to work with the language that you are targeting. For open source models, go to Hugging Face. In the Tasks tab, select Sentence Similarity. After that, click on the Languages tab and select the languages you need. The search result will show you the models that support the languages that you selected. You can also find how many languages a model was trained on by reading the model card. In this case, we can see that this model was trained on 70 languages. For closed source models, check the official documentation or read the release blog post. Let's test the models on the English dataset. In the previous video, I had almost 400 questions, but now I was able to generate another 400 questions, and here are the results. We can see that Gemini is performing better than the other models. And if we look at the average, we see that the top 3 models all have a score greater than 70%, and the all-mini LM is falling behind. So it is the worst performing model in this list. I have also added another 400 questions. So this is the maximum amount of questions that I generated from those documents. And we see that the Qwen 3 embedding 4B model claimed the first position back. But if we look at the average, we see that the scores are very similar. And this is expected because these models are trained on English. So that's by default, all these models will perform well on the English language. But when we move to other languages, we see that some models are going to start to perform badly because the amount of data that they was trained on is less than English. Now let's see how these models are going to perform on the Arabic dataset. It's the same dataset, I just translated it from English to Arabic. Here are the results. We see that Gemini this time is performing better in both cases. And if we look at the 1200 case, or both of them, we see that the All-Mini LM is getting a very low score. This is the score that I showed you in one of the previous slides. And this proves that you need to be careful when choosing a model. And here All-Mini LM was not trained on Arabic. We also see that the OpenAI models, they also struggle with Arabic. So the score is not 0 like the All-Mini LM, but it's 50%, which is low. And if we look at, let's go down here. If we look at Gemini, Qwen 3 embedding 8B and 4B, they all perform well. So we see that the score is greater than 70%. That's great. This means that both these models are multilingual, which means that they were trained on multiple languages. And we are going to dive deeper into this concept, multilinguality, in one of the upcoming slides. Let's also compare the scores between English and Arabic. Here I took the 1200 questions set, and we see that the rankings are almost similar. We see that All-Mini LM is always last. We have the OpenAI small and large models. And after that, we either get Gemini embedding in the first position or the Qwen 4B model. And if we look at the scores, we see that the scores didn't drop too much, especially the top three performers, one of the Qwen models and Gemini, they always get a score higher than 70%. But if we look at the OpenAI models, the performance dropped from 71% to 59%. Now let's talk about multilingual embedding models. This is a fascinating part. I really love this thing about embedding models. And the question here is, how does the model handle two languages at once? The model doesn't just match words. It learns the abstract meaning of the text. Let's say I took the word learning in English. If I translate that to Arabic, the vectors that represent these words will land in the exact same spot in the vector space. Look at this chart. The blue dots are English questions and the red dots are Arabic questions. You can see the questions are clustered together based on the topic, not the language. And this is what I am showing you here. Here we have 2 points. They are very close to each other. If you calculate the distance between them, you will get 0.00 something. And here I am showing the question and the translation. So if you can read Arabic, you will understand that these two sentences are basically the same. And when using a multilingual model, we see that the embeddings are located at the same position. This is so cool. Training embedding models on different languages makes them learn the meaning of concepts in different languages. The learned space becomes language agnostic. Since we are talking about multilingual embedding models, you can store documents in different languages in the same index. This makes retrieving information simpler because you don't need to manage multiple indices, one for Arabic, another one for English, and another one for French, let's say, if you are targeting these three languages. You can put all those documents into one centralized index if you decide to use a multilingual model. However, performance might drop a little bit compared to single language indexes. This is because we will add a little bit of noise when we merge those datasets into a gigantic dataset. And the noise happens because the vector space gets crowded. When you add more languages, the chance of an English query accidentally landing near an unrelated Arabic document increases. And this is called interference. This happens a lot especially if a model is not trained well on certain languages. Those languages might add noise in that embedding space. And here I'm showing you a table where I merged the English and Arabic datasets into one dataset that contains 2,400 questions. And we can see that the average dropped a little bit. Before it was higher than 70%, but now it's around 68%. It's not a big drop, but this proves what I mentioned now. If you decide to merge the dataset, you need to use a powerful multilingual model so that the performance or the accuracy does not drop. But if you don't like the idea of merging documents in different languages in one vector store, we can try something else. We will perform 4 tests with these combinations. In the first one, we will ask questions in English, and the index will have text chunks in English. In the second one, we will keep the text chunks in English, but we will ask the questions in Arabic. The third test is similar to the second one, but the questions are going to be in English and the text chunks are in Arabic. Finally, both the questions and text chunks are going to be in Arabic. Here are the results of those 4 tests. The results are really cool. At first glance, we see that the average score did not drop below 70%. Let's look at the top model in each benchmark. We see that here we have 75%, 72%, 74%, and 73%. This is true only for models that are trained on multiple languages. But again, if we come back to our friend all-mini LM model, we see that yes, it performed okay in the English case, but when we start to include Arabic, this model quickly starts to degrade. Here we get 0.09, 0.08, and 0.06. We also see that the OpenAI models are average. They perform similarly to the smallest Qwen model. For example, here in the English case, they perform well because that's the main language, but when we ask questions in Arabic, we see that the performance drops by a lot. So here it was 71%, now it's 52%. It drops by 20%. That's a lot. And here, as I mentioned, the large model is performing like the smallest Qwen model. And sometimes that model beats both of them, especially in the Arabic case. The stars of the show are Gemini and the Qwen 3 4 billion and 8 billion models. I really love these models, and sometimes you can see that sometimes the 4 billion model performs best, sometimes the Gemini model performs better, and sometimes the 8 billion model performs better. In our course, we are not trying to generate a big benchmark like the MTEB leaderboard that I shared with you multiple times in this course. No, here we are trying to create a representative dataset, a benchmark that is going to be used by you or inside the company where you work, where you are going to collect documents on a specific domain. Let's say that the domain is astronomy, and let's assume that this domain doesn't exist in the MTEB leaderboard or any other benchmark. In this case, you care about this domain and you don't care about other domains like technology, healthcare, or others. Collect as many documents as you can in the astronomy domain, extract the questions and the text chunks. If you can generate 1,200 questions, 2,300, that will be good. When you create that data set and benchmark the models, you will get how those models perform on that data set. And you don't care if Gemini is better at healthcare or other domains. All you care about is the astronomy domain. And this way you will have something specific, something niche that will tell you which model performs well on that specific case. And of course, if you don't care about other languages, you can keep that dataset in the original language. And by creating that dataset, you will be able to test new models on it, because you will create a table like I did here. And after that, when a new model comes, you will use the notebooks that I showed you, quickly benchmark that model and see where it lands in the table. If you see that this new model is better than the rest on that specific domain that you care about, you say, now we have a new model. So you can use it in your applications and see how it performs and see if it actually improves the performance of your applications. This is why I created this course, and this is how to benefit from it. Because yes, the MTab leaderboard is great. It gives you a holistic view of how these models perform on hundreds of tasks. But sometimes some tasks are not going to be there. So it's your turn to create a dataset on that task to find the models that perform best on that use case that you care about. That's enough for the theory. Now let's go practice. Before showing you the code, here is the GitHub repository that I was talking about. If you scroll down a little bit, you will find this note. When you click on this link, you will be able to find the repository on Hugging Face. And here I have uploaded all those documents that you can download. So if you open the datasets folder, you will find two versions. Here, for example, this file is the English version and the other one is going to be the Arabic version. So just download these one by one by clicking on them here, or download the whole repository. And when you do that, put everything inside the embedding folder. Open the Explorer, open data, create this folder, and put your JSON files here. After you do that, you need to open one of these notebooks. So I have created 3 notebooks for this step. Here we have a way to translate text with Gemini and OpenAI models. These are closed source models. And if you want to use an open source model, I have chosen Aya. This one is a special model. It was developed by Cohere Labs, and this model was trained on multiple languages. And the good thing is that this model is open source. You can see that if you open Hugging Face, you can find that model here. And they have multiple versions, so you can install the small variation, 8 billion, and they have the 32 billion. So I'll show you how to use that. But with open source models, you can use any model. Just make sure that it is trained on multiple languages so that you get good translations. Let's start with Gemini. The first thing here, we define the language. I chose to define Arabic. And here we are going to just set up a system prompt. So this step is not complex. The only thing that you need to work on is the system prompt. And here you can see that the system prompt is not that long. We explain the task to the model. And here we are telling it that the role is a word-class translator. And we give it some instructions. We don't want it to add or remove anything from the original text. We want it to stay the same, but to be translated. We need to maintain the original tone and return the translated text without any additional commentary or explanation. So we don't want the model to say, okay, here is the translated text. We just wanted to give us the translated text. And after that, we give it the language that we want to translate into. So let's run this. After that, I create a Pydantic object so that I can extract the text easily. And in this cell, I load the data. So I chose one of the documents that I uploaded, and I'm going to load the text chunks and questions for that specific document. In this case, we have 43 text chunks and 377 questions. And in order to use Gemini, we need to create an instance of the client and start. here you can see that we are using Gemini 2.5 Pro. And now we have the option to also choose the Gemini 3 Pro because it was released recently. But I'll keep 2.5 Pro because the new Gemini is under stress, so you might get rate limited. So that's why I will keep it as 2.5 Pro. And the logic is the same. So you use the generate content method, you pass your system prompt and the text here comes from the chunks. So here we are going to start by translating the chunks, and after that we will translate the questions. And you will notice that I added two variables, max retries and initial delay seconds. I did this because I was getting rate limited when the new Gemini 3 Pro was released, and I wasn't able to run this loop without getting errors. So I added a retry mechanism to keep retrying up to 5 times. And this helped me get over that problem. And this is how it works. So first you put a loop inside the first for loop, and this loop will run max retries times. So in this case, it's going to run 5 times if we get an error. But if everything succeeds, we are going to break out of the loop. And here we have initial delay seconds. So when we get the first error, we are going to wait for 2 seconds. But after the first error, if we get another error, we are going to multiply that delay by 2. So we are going to wait 2 seconds in the first error. After that, we will wait for 4 seconds, 8 seconds, 16, etc. We are doing it like that so that we give the server a chance to maybe recover, to get healthy, so that we don't get errors quickly. So that's the logic here, and as the rest is the same. So and as you can see, this is what I was getting. So the server was always responding by the model is overloaded, please retry. And you can see that here is the first attempt, the second, the third, etc. And the fourth succeeded. But if we didn't have this, the code will stop and we'll have to retry from the beginning. And it takes a lot of time, and I really didn't like how it behaved. So that's why I added this. So let's run this. I will add a break statement here to translate just one chunk. And let's see if this time it's going to work. And yes, it did work. You can see that we didn't get any error, and this inner loop stopped after getting a successful iteration. And here, when I take the translated text and put it back in the dictionary. So now if I take the text chunks list and look at the first element, we should see that it was translated. So if I go and take a look at the first element in the list, you can see that now it's in Arabic. And some text was not translated because that's the name of the company, and yeah, it's the model did a great job, so it kept it in the original text, but the rest was translated to Arabic. So that's working. And we are doing the same thing in the next cell, but instead of looping over the text chunks, we are looping over the questions. And yeah, after that, you see I was getting a lot of errors, but at least the code didn't stop and I was able to translate everything. Finally, we need to save the files, and I decided to save them in the same place. So if I look at the chunks, you'll see that I have the original documents that we worked with before, and this one doesn't have any suffix, so this is the English version, and the version that was translated has a suffix, and this one has the Arabic suffix because that's the language that I targeted. And we have the same thing for the other document. And yes, you can add more languages if you want. Here I just stopped at Arabic, but if you want to add French also or other ones, feel free to change the target language variable here and rerun the notebook, and you will get another file stored here. So this is how you use Gemini. And to use OpenAI, it's the same thing. So you just change the library. Instead of using the Google Generative AI package, you use the OpenAI package. So I'm not going to show that. And with Aya, we have the same thing. So here, because the Aya model is a big model, I decided to use, again, the GGF format. And here I used the bigger version. So I used the 32 billion model, and here I linked to a repository where you can find the GGF format, and feel free to download the one that works best on your machine. I always go with Q4 because I don't have a lot of resources, but if you have more, we can go up to Q8. Or if you don't have a lot of resources, you can go down to Q2, or in this case, we don't have Q1, but you can use Q2 if you want. Okay, so here is the AI model. And as I said, it's not required to use the AI model. You can use, for example, Gemini or Qwen. All of those models are perfect. They are trained on multiple languages, so you can use them. But here I'm trying to show you that in the open source ecosystem, we have a lot of options to play with, and that's a great thing. Here is the command that you should use to run the AI model. Because this one is big, I wasn't able to offload a lot of layers to the GPU, so I was able to offload just 5. This is not good because the model will run very slowly on my machine, but if you can, make sure to increase the value in the number of GPU layers parameter so that you can get faster responses. And yeah, let me show you again how to do this. You copy the command, you open the terminal, and you run it. And if you see this message, it means that the model loaded successfully and we can use it. Now go back to the notebook and run the following cells. So the system prompt is the same as the one that I defined in the Gemini notebook. Here we load the data, and here is the method that we will use to translate the text. First, we specify the endpoint and make sure that the port is the same one as the port that you specified in the command, so that you don't get any error. And inside we have the same thing that we worked with before. So you have a list of messages, you put the system prompt in the first item, and after that you add the user message, and in that role you put the text that you want to translate. And after that you make a post request to that endpoint, and if everything went well, you decode that response and you should get the content, which hopefully will contain the translated text. Now run this cell, and here I will add a break. And you see that here I didn't add that retry mechanism because the model is running locally and we will not hit any rate limits. We don't need it in this case. So let's run it, and let's go back to the terminal. You see that the number of tokens is 1335. That's a lot. Actually, let me stop this because it's going to take some time, and let me do it. Okay, so these are the text chunks. Let me do it in the questions because the questions are not big, and hopefully they should be. Yeah, you see that here we have just 148 tokens, so we should be able to translate them quickly. While waiting, I want to show you the output. And yeah, for those that can read Arabic, you can read this text and you will see that it's perfect. I really like this model. It does give good translations, and I like that it keeps terms like Asus computer, things like that. So the model does not tries to translate them to Arabic, and that's a good thing. But if you don't like that, you can take the text and modify it manually to change these terms. Okay, here I have a bug. So here response it's just a string, so it shouldn't be response.text. But as you can see, the text was translated to Arabic. That's good. And here, yeah, I need to fix this. So I need to remove .text so that we don't get that error. Good. And after that, you save the translated data. After translating your documents, you can use this notebook or the other two that are meant to be used for benchmarking. And this one, the third one that I added for this video, will perform those 4 benchmarks that I mentioned. And this notebook uses the same code that we have in the second notebook. So I try to put everything inside one cell just to make things quick. So here in the first part, we load the data. You'll see that in the Arabic dataset, we have 120 chunks and 1200 questions. And we get the same number in the English version because they are the same. And here we have the benchmarks section, and in this cell I have merged all the codes that will perform the benchmark, print the tables, and everything, because this is going to be used by all the 4 benchmarks that we are going to perform. Just to show you, we have a function that creates the Q roles, a function that will create the runs, and these are things that are used by the ranks library. The print benchmark report is a function that will print the tables. It's going to use the rich library to give us a nice table. And you can see that the code that we need to run to perform the benchmark is very small. For example, here in the first test, where we have questions and chunks in English, you see that this is the code, and when you run it, you'll be able to see the table. And this is exactly the table that I showed you in the slides, and let me show you how that works. So first, we need to create the runs for each model. Here, the models to benchmark are always those 7 models. Here they are. So we create a run for each model, and we append them to the runs English list. After that, we create the Q roles, and we pass both of them to the compare method. And after that, you can see that here we are using statistical testing. We provide the maximum probability and the metrics that we want to see in the table. And the print benchmark report will take the output from the compare method, and it will give us a nice table. This is the first test, and you see that most models perform better on this one because we have the English language. But in the second test, we change just the questions. So runs will not change, but here when we create the Q roles, we will pass the Arabic questions. We will not pass the English questions. So when we do this, we'll get a different result. You see that the all-mini LM doesn't perform well on this benchmark, but the rest are doing great, especially the Gemini embedding model. If we swap the English and Arabic in the third test, we get a similar result. And yeah, you see that the all-mini LM doesn't perform well, but those 3 are always on top, and the average score is always higher than 70%. And in this specific case, we change the runs. You see that here we provide the Arabic chunks. We don't use the English chunks, but since the questions are in English, we pass the English questions to the create Q roles method, and the rest stays the same. And for the final test, we pass all the Arabic variables. So we pass the Arabic chunks and Arabic questions to the create run and Q roles methods. And finally, we get this result. And you see that in this case, the OpenAI models are suffering. The performance is okay. The all-mini LM is not good at all, but Gemini, Qwen 3 8B and Qwen 3 4B models are doing really great on these 2 languages. So that's it for this video. See you in the next one.